Welcome back, geometers. This is Miss Prenner bringing you our next video. So I know last class you would have learned about using radicals and radical operations. That would have been an algebra review. Here we're going to launch into sort of the meat of chapter 8. And I would call today's lesson properties of right triangles, one of which I think you know very well and one of which I think will be new to you. We'll start with this new one first. This is hypotenuse midpoint theorem, which says the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. So what that says is A, B, C. So if M is the midpoint of the hypotenuse of right triangle ABC, then AM equals MB equals MC. All three of these lengths are the same. I'm not going to prove this per se, but I am going to say that if I were to sort of duplicate triangle ABC along that same line, you would all agree that this is an imaginary rectangle ABCD, and that this length would actually be the diagonal of ABCD. So again, the really quick why here is that if I were to form this into a rectangle where each side of this is a diagonal, so here's my first triangle here, not terribly straight, but you know, proof of concept. Well, then a mix of parallelogram diagonal theorem says that both of these diagonals are bisected by each other, so we know M is the midpoint of both. And rectangle diagonal theorem says that each of the diagonals are congruent. So using some combination of midpoint theorem and a little bit of transitive property, it should be pretty easy to get that all four of these lengths are the same, and therefore AM, MB, and MC in particular, that these lengths are all going to have to be the same. So the midpoint of the hypotenuse is equidistant to each vertex. All right, let's move on to the Pythagorean theorem, a very well-known theorem. All right, so this says in any right triangle, the area of the square whose side is the hypotenuse is equal to the sum of the area of the squares whose sides are the two legs. It's a lot of words for in a right triangle with legs length A and B and hypotenuse length C, we know A squared plus B squared equals C squared. Classic, well-known thing. I'm sure you've all heard this before. Now, why is this named after Pythagoras? He's credited with this theorem. Pythagoras was born about 570 BC. Died about 495 BC. He's credited with the theorem. However, there's no evidence that he actually wrote a proof. Turns out about 200 years earlier, in the 8th or 7th century BC, it's about 200 years by Pythagoras, a mathematician named Bodhayana wrote the Bodhayana Sutras. They were a group of Sanskrit texts about daily rituals and mathematics that included the following phrase that said, a rope stretched along the length of the diagonal produces an area which the vertical and horizontal sides make together. So again, if we've got some diagonal, compare that to the vertical and horizontal, the area produced by that length of the diagonal equal to the sum of the areas formed by a vertical or horizontal, aka a squared plus b squared equals c squared. It turns out that Mesopotamian, Indian, and Chinese mathematicians all independently discovered and proved this theorem before Pythagoras did. So why does he get credit? I don't know. Don't ask me. Textbooks. I would call it Pythagorean's theorem. Because math was done all over the world in ancient times, I'm getting a little sidetracked here, they weren't really emailing each other in, the ancient world to say, hey, I discovered this theorem, it's mine, don't take credit, which means a lot of discoveries were happening concurrently or happened hundreds of years before someone else would have even known to think about it. Who gets credit in the ancient world is a little bit complicated. Regardless. Proof of Pythagorean or Pythagorean theorem. There are many proofs. I'm going to use an algebraic approach that starts with 4 copies of the same right triangle that I've sort of arranged to form a square. So all of the hypotenuse form a square. So we've got this length A, and this length B, this length A, this length B, this length A, and that length B. You can see all of our triangles. Here's all the C's. So we have a couple different ways of finding the area. We could just take the area of the whole thing. We could do length times width of the whole sort of structure here, right? The area of the whole square, like that. Or this whole square is a plus b by a plus b. So that is a plus b by a plus b, which if you distribute with the FOIL method is a squared plus 2ab plus b squared. That is one way to do it. Another way would be to add all of the areas. So that would be by saying, okay, well, I see that we've got 4 of these triangles of length A and B. We've got 4 of these, and then 1 square length C. Or, sorry, with side lengths C. So find the area of all the squares. We know the area of the square is just C squared. And we can add up 4 times the area of a triangle is 1/2 base times height, which in a right triangle is 1/2 times the 2 legs. So that's 1/2 A times B, or 2AB plus C squared. Now we all agree it shouldn't matter how I calculate. So these areas are equal, which means that a squared plus 2ab plus b squared, the area I used finding the first method, should be equal to the way I found it with the second method. And you'll notice we have this 2ab on both sides. So if I just subtract 2ab from both sides, we get a squared plus b squared equals c squared. So this is the quick algebraic proof of Pythagorean theorem, although there are many others. Let's try using it. Set up an equation, find the value of x. Okay. So the second one is a concept check I'll let you work on. But here I can consider A, B, and C, legs and hypotenuse. The hypotenuse is always across from the right angle. So I have x squared plus x squared equals 7 root 2 squared. Now, squaring a radical, we learned a little bit about last time, but I'll take this slow. I know 2x squared combined like terms is going to be 7 root 2 times 7 root 2. That's what it means to square something. You can multiply the whole numbers, that's 49. And you can multiply these squares, and we know root 2 times root 2 is just going to be 2. So I know 2x squared is going to equal 49 times 2. 2x squared is going to be 98. And if you divide it by 2, divided by 2, we know x squared, sorry, handwriting, x squared is equal to 49, and we'll square root both sides. And your Algebra 2 teacher want me to remind you that you can get x equals 7 or negative 7, but from a geometry perspective, we can't have a negative length. So there's our answer. You should try the same thing with question 2. So here we have a different concept check where I have here 8, 6, and blank. I want to solve for x. I might actually just call this little length y. I know these triangles are congruent because this is an isosceles triangle. And I have a reflexive length and I have a right angle. So by RHL, I know these are congruent. I'm going to call that y for a second. So if I find y, I can just double it and I'll be able to find x. So here I can see that y squared plus 6 squared equals 8 squared. So y squared plus 36 equals 64. 64 minus 36 is 28. And we square root both sides. 28 is not a perfect square, so that requires me to figure out what its factors are. I know it's 4 times 7. 4 is a perfect square, which means that y is equal to 2 root 7 or negative 2 root 7. But again, we can't have a negative length. And if x is double that, I know x is equal to 2 times 2 root 7 or 4 root 7. All right, this other one is also a concept check. I would encourage you to use some of your quadrilateral knowledge to help figure out how to set up for Pythagorean theorem here. Thank you so much for your hard work. I hope this very quick lesson made sense. Finish your notes, finish your concept check. And, oh, we have word problems. I forgot. Do not make good choices yet. Make good choices after we finish our notes. A rectangle is 2 centimeters longer than it is wide. The diagonal of a rectangle is 10 centimeters long. Find the perimeter of the rectangle. I'm going to start by drawing a picture off to the side. So here's the diagonal of my rectangle. Could be either diagonal, they're congruent. So if I make this x, we can make this x plus 2, and I know that's 10. So let's set up Pythagorean theorem. We have x squared plus x plus 2 squared equals 10 squared. So here I see that I have x squared plus, I'm just going to distribute by the FOIL method, and I'm going to get squared plus 4x plus 4 equals 10. We're going to combine like 100, sorry. We're going to combine like terms and get 2x squared plus 4x plus 4 equals 100. I notice each of these numbers has an even factor to them. So I can just divide the whole thing by 2. When I divide the whole thing by 2, I mean I divide literally everything by 2. So I get x squared plus 2x plus 2 equals 50. So we have x squared plus 2x minus 48 equals 0. So we get x plus 8 and x minus 6 equals 0, which means x equals negative 8 or x equals 6. And again, we can't have a negative length, so that doesn't work. So we know now x is 6. Now I wanted to find the perimeter of the rectangle. So let's now draw my rectangle again. I have length 6, x plus 2 was 8, and we know that's 6 and that's 8, so the perimeter is equal to 2 times 6 plus 8, which is 14, or 28 centimeters. And I believe that is the last problem we had to work on. So now I hope this helped. Make sure to finish your concept